Okay, so this next unit, even though we've worked with exponentials and that was unit 9 and we didn't quite get to close that out in a traditional way with like a quiz or a test, thanks to the benchmark, we will review that and do some closure, but just not right this second. We need to go ahead and move into unit 10. I titled it Statistical and Geometric Concepts for Math 1, okay? So this class period, all I want you guys to do is focus on the geometric concepts, distance and midpoint. And the good news is they're not really new ideas. You already have the math skills. You just need to follow along on your guided sheet so that you can use my examples to help you do your classwork. Okay, so the first part says we're going to look at distance. We've got this story problem that says we've got a map of a park. It's been duplicated with a coordinate plane overlay. The swing set has been labeled S, located at 6, -3, and the pond has been labeled P, located at -2,5. If the map is scaled so that each unit on the plane represents 1/10 of a mile, determine the approximate distance between the landmarks if one were to walk a direct path from one to the other. So that's super wordy, but just like with anything else geometric or when you get ordered pairs, it helps to think about what that looks like. So I'm going to quick sketch a graph that shows the swing set at 6, -3, 1, 2, 3, 4, 5, 6, 1, 2, 3. And label that S, and the pond at -2,5. 1, 2, 3, 4, 5. About there, and I'll label it P. So if I want to know the distance between these on the grid, then it helps to connect them. And when you all were in the 6th grade, you could use the spaces to count vertical distances and horizontal distances. However, now you're interested in oblique lengths on the plane. So what we're going to do is use what we already know for distance. We're going to create the right triangle between the points so that we can use or apply the Pythagorean theorem. So the good news is we already know how to talk about vertical and horizontal distance. We know how long the legs are. Down here at -3, we would be all the way up here to 5. So vertically, 3 plus 5 means that this leg is 8 units long. And the horizontal leg, we're over here at +6 on the x-axis, and we need to go toward the left. There's 6 spaces and 2 more. Make 8 units on this leg. And there's our right triangle. So if we know how to form the triangle on the coordinate plane, then we can go ahead and say that this distance between the park and the the pond and the swing set, that distance becomes d squared, the hypotenuse squared is 8 squared plus 8 squared. Pause for me.
Okay, now it is.
Okay. So, sorry I had to pause. But anyway, you guys know how to solve for d. This would be d squared is equal to 64 plus 64 is 128. And so d is the square root of 128, which is approximately 11.5-ish, maybe? Yes, 11.5. Because the square root of 128 sits between the 11 squared, which is 121, and 12 squared, which is 144. So it's 11 and just about 0.5 if we round to the nearest 10. So if I know that on the drawing that this is 11.5 units, The story says I'm not going to choose the answer choice 11.5 because it says each unit on the diagram represents 1/10 of a mile. So I have 11.5 of these 1/10 of a miles. So to answer the question, I would need to say 11.5 of these 1/10 miles. And we know in our heads that dividing by 10 just moves this decimal place over to the left 1/10 place. So we would say that the answer is that the pond and the swing set are about 1.15 miles apart. Okay, so that's one example of how we can use what we know about Pythagorean theorem to solve for the distance between points. The other thing, guys, is that when you go to the high school next year, you will have some people who don't think about the fact that you know the Pythagorean theorem, and they may tell you the distance formula looks like this: the square root of your horizontal change squared plus your vertical change squared. And all that is horizontal leg squared, change in x's, plus vertical leg squared. And then at the end, we took the square root. So the distance formula is Pythagorean theorem. If you see this at the high school, you just know that you make the right triangle, do Pythagorean, and that's the same thing.
Wait, can we pause for a second?
Go ahead.